Hi, everyone. Good evening to all. So, we are here to learn some pharmacology analytics. Pharmacology analytics, right? Before entering into that analytics, let's speak about the program. This program will have for 16 hours, 16 hours, 1.5 hours a day. We will be 4 to 5:30. The program will be 4 to 5:30 p.m. Right? So we'll be having number of days here. So we'll be encountering day 1, day 2, day 3, all these things in a progress, in a simultaneous process. Okay, fine. Now you have chosen an best institute to study, that is 360DigiTMG, where you will keep on developing your knowledge, your skills, everything here. People who ever done the courses on 360 and whatever they did on here, they are at good positions right now. So I recommend you people to watch the video completely till the day, till it end, so that you will have a sufficient amount of knowledge regarding the pharmacology analytics or pharmaceutical analytics. Okay. So we are the only one in India covering around 75 plus domains. Proudly, I have to say this. People know no one have started this many domains. We are providing 75 plus domain analytics program, domain analytics program. So please make use of this. People can look into a lot of analytics in our YouTube channel. So please subscribe to our YouTube channel and click the bell icon to get a notification for the periodical times, and any new videos or recommended that will be uploaded to you, that will be updated to you. Okay. So let's get into the topic of pharmaceutical analytics. So data science and machine learning in pharmacology. So you know that nowadays everything is in everything. Every business decisions are made based on the data science and machine learnings. Here we see generally what is pharmacology or pharmaceutical analytics, what it is mean generally, what a pharmaceutical means. Anyone? In general term, a pharmacologist or pharmacology or pharmaceutical focus on some chemical drugs, right? It focuses on some chemical drugs. And how they affect the people, how they affect the people. Affect the people. It focuses on chemical drugs and how the drugs affect the people. Not only people, the organisms, okay, which consume them. The following drugs, there are a lot of drugs nowadays, which will affect the people and how it is affecting, what are the chemical process it's being done. This speaks about pharmacology, where it focuses only on the chemical drugs. Pharmaceutical or pharmacology, it focuses on the chemical drugs. So a pharmacologist is responsible for developing the drugs. Pharmacology responsible for developing the drug that safely dispensed to patients. which is very safe to the patient, very safe to the patient. So overall, a pharmacologist will deal with the drugs, and their responsibility is to give a good amount of drugs. That is, people who consumes it do not get affected by any other things, right? So that is our main aim here of pharmacology. These are the very in layman terms. This is what you need to know about the pharmacology. It's not a pharmaceutical. Okay. Or the quantity of product may deviate from the standard requirement, but in carrying out an analysis, one also has to certain that the quantity of the analysis itself is of a standard requirement, which means it should be in a standard requirement. Like, you know, that whenever a drug is developed, whenever any material will take, it's based on a standard, industrial standard. All over the world, there will be some industrial standard. This is how the chemical content to be added. This is how the drug powerful should be there. All these procedures, all these rules should be followed here, right? So while testing a pharmaceutical product, which involves chemical, physical, and sometimes microbiological analysis, what it means. See, when we check the drug, let's say, while we check the drug, okay, how the testing will happen? Basically, it will happen through a chemical process. We might have seen that in a chemical beaker, they'll add some amount of chemical substances to extract the how many percentage of drug is added in a particular medicine, and how many percentage of chemical is added in a particular medicine. So that is how they will look into that, right? So once they got it, they will have some techniques that speak about chemical, physical, and sometimes a microbiological. You might have heard that using some high uh, telescope, something they'll use, look into the drugs clearly, what is inside that, what pesticides are used, and what are the things they are used into the drugs. In such a way, it will be visualized. There is a survey says that 10 billion only for, okay, 10 billion is spent only for an analysis in London alone. In London alone, for this drug analysis, 10 billion, okay, each year in London. So like this, in every countries have their own specific amount to be invested in the analysis process of the drugs. Okay, this analysis not only done here, it also food, beverages, cosmetics, detergents, metals, paints, waters, agrochemicals, biotechnological products, pharmaceuticals. Okay. So why this are doing? Because to have the quality of the product, quality of the drug, the required quality should be there, right? This is a utmost priority need to be given to this, or else people will get affected because of this. So utmost priority should be given for this. I need to do some precious analysis, right? So we will be encountering the pharmacology analytics in this complete sessions, right? I hope it is clear what is the general in lame terms, what it means. What are the questions that analysis are conducting? What are the questions they'll ask? Is the identity of the drug is formulated product correct, or how many percentage of drug is added. Does this formulation contain solely the active ingredient, or additional impurity percentage added, or is it stability of the drug is in the formulation, uh, or concentration of specific impurities in a pure drug? What are the concentration level they will look into? They will look into all this kind of analysis in the pharmaceutical, and they will measure all the level of percentage what is going on here. So the requirement for control of the quality of the method of analysis have been addressed by the International Conference of Harmonization of Technical Requirement. That is also a short term. It is called as ICH. It was initiated by some Brazil in 1990 and brought together representative of regulatory analysis and industry associates of Europe, Japan, and USA. Okay, they will look into this analysis processes. Okay, this is how the basic about it. So I hope that there is some knowledge about the pharmaceutical now, pharmacology, at least some amount of information that you might have gathered it. Right, we will be encountering this into the upcoming sessions completely. So no other new things. So we'll be focusing on entire about this through the whole process. So yeah, we don't want to get so we'll be doing all the machine learning processes into it. We'll be doing a Canon. So there are certain algorithm which will take some use cases. We'll be doing the use cases, and we will be doing all the algorithms here, performing k-means with a clustering, Canon. I hope it is a bit clear now. I know that a pharmacist will split into practical settings and practicals and others, that is a community, a hospital, clinic, and also academics, clinics, research, regulatories. In some industrial purpose, they'll use some production of the drugs, quality assurance, R&D department like bulk drugs and formulations, then quality control, packaging, regulatory, sales and marketing. All this will happen, right? We all know in a lame term, if you want to say that a pharmaceutical analysis is a branch of science which deals with the qualitative and quantitative and semi-quantitative estimation of given pharmaceutical samples. It speaks about the samples, what quality, what quantity, and the semi-qualitative. So what is this chemical process? Is it resolution of chemical components into some proximate or ultimate parts? While analyzing this, the prime importance to gain information about the qualitative, what's the quality and quantitative composition of substances and chemical species. That is to find out what a substance is composed of and exactly how much. Okay. I hope you are clear about what is qualitative, quantitative, and semi-quantitative. I don't want to give much. Let's discuss into small things. So when you speak about qualitative, which analysis are present in the given sample? What analysis that in the present sample? Then how much amount of analytic present in the given sample? Analyte is present in the sample. When you speak about semi-quantitative, this is like a type of analysis which only describes whether the quantity of impurity present in a given sample is below or above the specific limit, such as a limit list, right? So what is the scope of this analysis? There are few scopes which we have discussed previously. I hope we have covered it. Few benefits of that analysis. The scope is like some biological sample estimation, food determination, like we said, foods, beverages, dairy products estimations, soil study, forensic determinations, pesticide estimation in food and vegetables, environmental pollutant determines. So all these are some analysis of it. What is the advantage of this? Accurate and simple. So all these things are there. So we'll encounter with some use cases along with this. So yeah, this is about the introduction part about the pharmaceutical analytics. So let us get into the next slide and what we speak about. So here in this day one, we will look into application of pharmaceutical analytics. We will see the application of it, how and where it is applied with some use cases. We will look into all the applications, how it works and how it goes. What are some use cases, like how the drugs are analyzed based on machine learning part, where it is exactly used. I have some use cases in upcoming slides. We will discuss that. In CRISP MLQ methodology. What is CRISP MLQ methodology? Now the point come. See, we will be following this entire subject with the CRISP MLQ methodology. First question is, what is CRISP MLQ methodology? Okay. See, before entering into CRISP MLQ, I want to say about the stages of analysis, stages of analytics. What does that mean? So let's take stages of analytics. We have descriptive analytics, first phase, descriptive analytics. What does this descriptive analytics means? Descriptive analytics speaks about what happened in the past. Descriptive analytics speaks about what happened in the past. Okay. What happened in the past? Let us take some example. Let's speak about some COVID cases. Let's see, in 2019, what happened? How much the COVID cases increased? What is the cause of it? All this analysis you would learn, that is called as descriptive analytics. The second stage of analytics is diagnostic analytics. Diagnostic analytics. Here in diagnostic analytics, why something has happened? Why something has happened? See, first I'm discovering what has happened in the past, what is done in the past, right? That is all. That is all. I'm not getting much into it. I'm just having what is done in the past. Leave it. Then why something has happened? Why something has happened? That is a diagnostic analytics. We analyze the past. Now we are thinking why it happened. diagnostic analytics. Third one is predictive analytics. Predictive analytics. What is likely to happen in the future? What is likely to happen in the future? So descriptive analytics will speak about what happened in the past. Diagnostic analytics speaks about why it happened, why this happened specifically. And predictive analytics, what is likely to happen in the future? What is likely to happen in the future, right? So what is likely to happen in the future? Now you go at the point, right? So when we take the COVID cases, I analyze something has happened in 2019, the cases are increased. And I'm analyzing why it has happened. That comes under diagnostic analytics. Then I'm saying what is going to happen in the future. That is predictive analytics. There is one more analytics here. That is prescriptive analytics. Prescriptive analytics. So in predictive analytics, we say that what is likely to happen in the future, what is going to happen in the future. In predictive analytics, what is likely to happen in the future in predictive analytics. So you will predict the future, what is going to happen. Now in prescriptive analytics, you will say, you will take some measures to prove that predictive analytics. That means you are predicting that the number of cases, COVID cases will reduce in the 10% you are saying. So what are the measures needed to be taken for that? That comes under prescriptive analytics. We are trying what are the various things can be performed to achieve my predictive analytics, like constraints to predict the analysis. Taking action based on prediction. Taking action based on the prediction. Sense based on the prediction is called prescriptive analytics. I hope it is clear now. What are the stages of analytics? How the things are analyzed. So this is the step we have to follow. First, we need to analyze what happened in the past. Second, why it has happened. Third, what is going to happen. And fourth, you need to predict. You need to take some measures to how to what is going to be what taking action based on the predictions. What measures we can take to make it true in the prediction. That is what we will do. So I hope that stages of analytics is clear, right? Now, let us discuss about CRISP MLQ. So CRISP MLQ stands for Cross Industrial Standard Process of Machine Learning with Quality Assurance. Cross Industrial Standard Process of Machine Learning with Quality Assurance. That is what CRISP MLQ is all about. Here we have some 6 phases in it. 6 phases we have in the CRISP MLQ. Phase 1. There are some 6 phases. What are those phases and how it works? So business and data understanding is the first phase. Business and data understanding. Business and data understanding is the phase one. Then phase two speaks about we know that what is business and data understanding, right? The same way, phase two will be speaking about here we have data understanding we done. Then we come on to model building. This model building phase, where we'll build our model. Second phase is for exploratory data analysis. Third phase is for model building. And the fourth phase speaks about evaluation of the model. Of the model. Fifth phase speaks about model deployment. And the sixth phase speaks about monitoring and maintenance. So we have 6 phases here. So business and data understanding. So for any given problem, we have to understand the business first. For any given problem, we have to understand the business first. Okay. And the data. Business and data understanding. So what the business problem exactly speaks about? That is the first thing which we need to take care of. What the business actually speaks about. That is the first thing. The second thing is exploratory data analysis. So first you will understand the business problem. And after understanding the business problem, you will start collecting the data based on the business problem. Once you start collecting the data based on the business problem, after collecting it, there may be some sources into it, primary, secondary sources, all these things will come into picture. After collecting the data, we have to do some analysis. That is called as exploratory data analysis. Exploratory data analysis. This exploratory data analysis will look into the data using this thing, what we can do, what it means and what we can do here. What are the errors, modifications that we can perform on this data. So what this does, Here we have some lot of steps like pre-processing steps are there and model building are there. So a lot of informations are available here. So we have to do outlier treatment. We have to do pre-processing steps like missing value imputation. Then a lot of techniques were needed to be followed here, right? After completing the data cleaning processes, after completing all the data cleaning processes, we have to do model building. We have to do model building. We have to build the model. Okay, we have to build the model. So the model building, we have a lot of machine learning models. Let's say a K means that is to cluster it. Then we have dimensional reduction, PCA, SVD, all this come under dimensionality detection. Once all this done, we will enter into the model building process. In model building process, we will do some, we will try to do the model like we have some k-means like KNN, K nearest neighbor algorithm, where we will perform it. So we can know, we should know what is that algorithm is used and how it will work. Then we have a decision tree. We have regression model, simple linear, multilinear, logistic regression. To overcome the drawbacks of it, we have lasso, ridge, all these things are there. So in this phase, you will create a model to predict the future of it. Using the data, you clean the data. Now you have a wonderful amount of data in your hand. Once you have this wonderful amount of data, you have to do the model building. Once you started doing the model building, okay, once you started doing the model building, we have to make at most some 16, 20 models to choose which is the best model out of it. So we have to try all the algorithms, which is giving some good accuracy based on the data. So we have to prove it and we have to apply all the knowledge into it. The model building process, right? So once the model building is done, once the model building is done, what we will do? We will evaluate the model. First, let us say when we have a data, some 1,000 rows in the data, 1,000 data points we have. What I will do, I will take some 700 data point for model building. Okay. I will take some 700 data point for the model building. Once I take the 700 model, 700 data and build a model, I will test my model now. I will test my model now. Okay. So when I test my model, when I'm going to test my model, okay, I'm going to test the model. The model should give some good accuracy around 95% or 96, 97. There is no 100% accuracy. That is for sure, we know. No model can give 100% accuracy. So there may be some 95, 94 like that. In pharmaceutical, it should be 99% accuracy. We can give some tolerance of 1%. That is too a problem since we are dealing with people's life. So we don't want to give that much amount of that much gap, right? So we have to give some accuracy. That is good accuracy, right? So that is 99.99% can be. That is somewhat good accuracy based on the pharmaceutical or medical industry, since we are dealing with the people's life. Then this is about the model building. Then we will evaluate the model as we are discussing now. We will start evaluating the model one by one. how the model will work, how the things will go in the model, what will happen in the model, what is happening in it. So we will evaluate the model. Okay. We will evaluate the model by using the 300 data points that is remaining. That let's say we say it now, some 100 data points will, some 1000 data points will have, 70 for model building and 300 for evaluation phase. So the accuracy should be good while I'm evaluating. Okay, fine. Let us assume that the accuracy is also good now. After completing the accuracy, we will enter into model deployment. We will enter into model deployment. We will enter into model deployment. This model deployment, okay, this model deployment, you have to deploy your developed model. Once you have a good accuracy on it, you have to deploy in your client's mission, right? That is the goal. We have to deploy it to the client's mission. Until we are deploying into the client mission, it is not going to be useful. So whenever we develop a model, we have to deploy it into the client's mission. So we will deploy using some deploying tools. We have Flask, we have Heroku, we have a lot of things out there to deploy the model. So we will deploy using it. So once we deploy the model, the client will run it and he will get some good results. So he will run the business wonderfully, and he will also get, he will run the business wonderfully, and he will also get some good what we call good amount from it, right? Once the business is going good, then the amount will also be good, right? Fine. Should we stop there? No. Our process is also included in monitoring and maintenance. We have to monitor it. We have to monitor on a periodical basis. Let us say client uses a database, some SQL database they are using to store the data. So the live data will be getting to the database all the time, right? We created a model for that data. So we need to update the data for the current model, right? We have to update the data for the current model. So in order to update the data for current model, in order to update the data for current model, we will do the monitoring and maintenance phases. We have to do the monitoring and maintenance phases. I hope it is clear, the monitoring and maintenance phases as well. So these are the 6 phases which we need to take care when we encounter a business problem. Starting to ending, we have to look into. There is no other way. We have to look into from starting to ending. Fine. Now, once this is about the crisp MLQ. Now, we will look into exploratory data analytics. Exploratory data analytics, I said, what is EDA? It is also called as exploratory data analysis. Exploring the data by analyzing it. Exploring the data by analyzing it. Clear? We are going to explore the data by analyzing it. Exploring the data by analyzing it. This is what exploratory data analysis means. What are the analysis you will follow? Outlier treatment. Since if your data is having some outliers, you need to do outlier treatments. Imputation. When we have some missing values, null values, Suppose we have some missing values into it or null values, then we will do the imputation process. We have a discretization. We have a lot of techniques are there, around 10 or something, that data analysis. So yeah, we will perform all these things to get a good amount of data. Good amount of data. So now let us assume you got the good amount of data. Now come under the clustering part. So in clustering part, what is clustering? Generally, cluster like group, we can say. Clustering is grouping. When we receive a data from any data source, generally, when we receive a data from any data source, okay, whatever the data source can be, when we receive the data, the data will be in the form of heterogeneous. What is heterogeneous? Mixture of all. Mixture of all the things will be there in that data. Right? Mixture of all the things will be there in the data. So heterogeneous data will have mixture of all the things. Let us say there may be some point which can be correlated with the other. There may be some point which can be correlated with the other. There may be some point. But it is not true that there is some point. But it can be. So in order to group the similar kind of data, we will do clustering. In order to group similar kind of data, we will do clustering. So heterogeneous data into a homogeneous data. Heterogeneous data should be converted into a homogeneous data. Homogeneous means separate groups, same groups. Heterogeneous means all mixture. Okay, that is what we will do in k-means clustering. This k-means clustering is an unsupervised. What is unsupervised? There is two you need to know. There is supervised building, model building, and unsupervised. Supervised, it will have the output variable into it. For example, let us say you can take a banking domain. In a banking domain, if you want to predict the person who is going to default and who is not going to default in a banking domain, let us say, okay, if you want to predict in a banking domain who's going to default or not default, so in order to predict it, okay, who is going to default and who is not going to default, the output variable will also be given. Let us say there is a previous data that few customers were there. When there is a few customers, from that customers, let us assume there is a few customers, there is some output variable. These guys are defaulted who paid the loan. These guys are not defaulted who didn't pay the loan. You have this kind of information for 1,200 people. Let us say 1,000, 2,000 people. So once you have this data, you have the output variable default or not default. Let us say there is a person called Karthik and his age is 25. He is getting a salary of 30,000 and he's having 2 loans in it already. So he's asking for a loan and you have provided the loan, but he is not paid. So when a similar kind of person comes with this criteria, then I can predict it, he will not pay the loan. So the output variable will be there, that is unsupervised. Output will not, like, that is supervised, and output variable will not be there, that is supervised. Like we can say all the data, max to maximum data will be an unsupervised data. It will be from outside only. Maximum data points are unsupervised data. Then KNN, K nearest neighbor. So this is clustering. This is not model building. This is clustering. We are grouping it. After grouping it, now we are starting doing the model building. We will learn K nearest neighbor. K nearest neighbor. We will do the K nearest neighbor. So what it is? So it will take, if you want to classify, let us say you have some, these are all supervised learning, guys. This KNN is a supervised learning. Okay. Let us say if you want to classify the tomato, or if you want to classify a drug, there are already two classes drugs are there. If you want to classify whether this drug will come under this category, that is a consumable or not consumable category, let us assume. So how this prediction will, this KNN will happen is, it will place the data in some point and it will take the nearest neighbor of it. And whatever the neighbor is nearer, like consumable is nearer, then it will take the consumable value that the drug is consumable. If it is the far and the non-consumable is nearer, then it will take non-consumable. So it will take the nearest neighbor. So this is my drug and this is consumable, this is not consumable. The distance between this will be calculated, which is the smallest distance. This drug will come into that. So like this, the K nearest neighbor algorithm will work. This is the one model building. Then we have decision tree. Decision tree will be like a tree-like structure. We can say a tree. Decision tree will form a rules. Lot of patterns will be formed. And in that pattern, which pattern is the best? From this, this, like this, lot of patterns will be there. You can take this as one pattern. You can take this as another pattern. You can take this as another pattern. You can take this as another pattern. So all these are the patterns we have, right? All these are the patterns we have. So rules and patterns we have. Then we have linear regression. Regression models. Okay. We will look into the regression models. So this is the third module. Then we will enter into multi-layer perceptron. This is totally into a neural network, friends. Neural network. We know that in our brain there are neurons, right? Something will be like this. This is, let us assume this is brain. Maybe my diagram is not good, but say no, I will not be good in diagrams. So there are billions of neurons, billions of neurons in human brain. So what if we create this neuron and we'll implement in robots? That is the neural networks, generating neurons, generating billions of neurons is the target. Neurons. What is a neuron? Let us say if you touch something, immediately sense will happen into our mind. It is hot, it is cold, like that. But the taste, if you walk something down, sense. So all this is because of neurons. Neurons do all these things. So here we will look into some multi-layer perceptron, that is neural network. where we have multiple neurons we will handle, and how will we generate with that. These all things we will discuss in the upcoming sessions, completely detailed with the use cases, right? Applications we'll cover today. Crispr Milky maybe tomorrow. Exploratory data analysis maybe tomorrow. Then we will encounter data mining, that is unsupervised learning, that is K means clustering we will discuss. Then KNN, then decision tree, then linear regression, then multi-layer perceptrons. So this is the flow we will go for the 8 days. Okay, so how many hours a day? 1.5 hours I said, into 8, how much it's coming? So it's like per day 1.5 hours, right? So 2 days it is 3 hours, and 4 days it is 6 hours, and 6 days it is 9 hours of program. And yeah, I think it will be more than this 80. So let us look into that. How many days it will take? We will may encounter some more algorithms as well. That is actually good for us, right? To have a number of algorithms that is going to improve our knowledge anyway. So we'll focus on these algorithms on a daily basis, and we'll perform all the analysis based on it. So let's get into and see some applications of this pharmaceutical data analytics. Okay, there is application stating a new drug must be developed around 12 to 14 years. Okay, which is a new drug you need to develop, costing $7 billion, and it must then to be introduced to a market, which takes even longer. The pharmaceutical sector is using data analytics to speed up this research. How? See, a research is developing a new drug need to be implemented, my business problem, within 12 to 14 years. It will cost $1 billion, that is fine, but it is going to take much longer time to enter into the market, right? So how a data analysis or data science can help in this thing to achieve my goal? That is the question here. How this is going to help us? I hope the question is clear. In pharmaceutical companies, data science can expedite trial and development and cut down on the production of these drugs. So pharmaceutical businesses can use these data analytics to locate their rivals and develop useful data strategies. In a competitive industry, Python and BioPython are two data sciences. Programming languages that businesses are heavily invested in, demonstrating the importance of data analysis in bioinformatics. So this is a business problem. How we are going to solve this? So the application of data science in drugs is there. How we can speed up the research process. This is a kind of application. Then we have some methodologies and processes to process it. So how speed up drug development and discovery. In this use case, it will be used in this is an application, how to speed up the drug development and discovery. What are the things you have to taking care? Boost safety and risk management. Boost safety and risk management. Have to boost it. Then machine learning and clinical research and development. Machine learning in clinical research and development. More effectively target particular patient populations. See, clinical researches, right? In developments, risk management. When we speak about risk management, even at the drug consumption by the patient, it is going to previously, you know what? In previous times, people are used for testings, for the medicines, injections, all these things. People are used for testing. So most of the lives were dead, right? Some medicine is going to be tested. There may be a lot of side effects. There may be a lot of fits. All these things are there, right? So people are getting died because of that. People are getting died. So what will happen? Then later they come to know that rat DNA is more or less similar to the humans. So they started testing with humans. They started testing with humans. So sorry, they stopped testing with humans. They started with the rats. So the risk management, even a rat, that is going to be an organism, right? So that is the risk management should be less. So we have to boost the safety of it. Then we have target particular patient populations, uh, improved understanding of the patient experience and behavior. So if a patient is consumption of that drug and how the experiences and how the behaviors in previous times when they consume the drugs and they consume let us say in nowadays the margina is consumed by a lot of peoples, so you can notice their behavior is changing tremendously, right? We can notice it quite a period of time. Their attitudes, their everything is keep on changing, right? So it is required. Then clinical studies, we have to effectiveness needs to be increased. So these are some applications. So, okay, sales and marketing firms. So even when we talk about the drugs, it comes under the drug sales and marketing, how the drugs are marketed and how it sells around the globe. We have to look into that as well, right? Speed up drug development and discovery. Speed up drug development and discovery. How to speed up it? The drug development. Pharmaceutical industry have altered over a recent year due to pandemics and escalating technical developments. Currently, businesses require information from conventions, academic publications, clinical studies, and patents. Sorry. So, uh, so if you want to do some analysis on product development and discovery, we need the data, right? So that data to be conventional and publication, clinical studies, and data to be patent. So this data more affordably with the aid of data science and analytics, which will aid in their research and development. Comparing the outcomes of recent trials and tests with those from earlier scientific researches also benefits businesses. For further insights into pharmaceutical and informatics, you can dwell deeply into the research and pertinent criteria. So this is how we will speed up the pharmaceutical analytics, right? How to boost safety and risk management. Companies must consider people's attitude and feelings when they releasing or testing new drugs. Companies must consider people's attitude and feelings when they're releasing or testing new drugs. The analysis of people's sentiments via the internet and gathering feedback for the companies and competitors can also be accomplished through data science and analytics. Right. So, yeah, while testing the new drugs, we have to see the attitudes, what people are reacting, what if you test on a rat, you have to check it out. What the rat does and what does the feelings it releases. This analysis of people sentiment via the internet and gathering feedback for their companies can also accomplish through data science. So that feelings you can capture, that attitudes you can capture, and you can gather the information using the data science and analytics. So machine learning in clinical research and development, how it is identifying relevant and irrelevant data, identifying relevant and irrelevant data for the intended target audience is a common challenge for data researchers and developers. Some of the best known algorithms for optimal audience targeting via data science machine learning are neural networks. So optimal audience targeting via data science and machine learning. Optimal audience targeting via data science and machine learning. We can do with the neural networks, deep learning, and Bayesian machine learning and Bayesian machine learning. So we will discuss the neural network part. I don't hope that, let us see if there is some time we will encounter this as well. Yeah, sure. Then we have a effective target particular patient population, how that it is. So these are the application, guys, how it is applied on the real world, how this pharmacology, analytics, how the data science is getting involved into it. These are the application of it. Every person has a unique capacity and character, right? We know that based on their genomical, that is DNA, the structure. They they are, or they also need unique treatments and biology based on their gene. Yes, by tailoring each medicine to the unique needs of each patient involve a huge number of process. See, everyone's gene is totally different, and everyone needs different treatments. So while creating a drug, okay, while creating a pill, medicine, we have to keep on all these criteria in mind that these are DNAs and it would adapt for all. So we have to keep these on our mind, and with keeping this in our mind, we have to do the analysis. So here comes our data science and data analysis work. You may streamline that process with the use of data science and analysis. You can streamline it. It searches through DNA sequence and devices data and use electronic medical records to track each person's physical change. To track each person's physical change. Right? Then we have a improved understanding of patient experiences and behavior. To develop better individualized treatments for patients, data science and data analytics can track the structure, genomics characteristics of a patient and analyze the patterns. The client's input can help them solid ideas for the development of their medicines. So to develop better individualized treatments for patient, can track the unstructured genomic characteristics of the patient and analyze the pattern. So the DNA patterns can also be analyzed by the data scientist and data analyst. The client inputs can help them to produce solid ideas for the development of their medicines. So this will help the client to develop the medicines. They can discover what causes patients to stop taking these drugs, right? There may be side effects that may be resulting in bulging of kidneys. There are a lot of side effects which is causing. There is a drug called melatoxin, so which is very bad for blood vessels. right? So that is side effect. So stop taking this drug, or which patient do not adhere to this prescribed dosages. There is some particular dosage should be consumed by a particular person, right? Machine learning, clustering, and scoring models can be used for businesses to determine which drug is most appropriate for this subject, which drug is more appropriate for this subject. Reacting to a certain product requires consideration of the feelings, opinions, and feedback of the customers. This is also possible with the data science and machine learning. Then boost the effectiveness of clinical studies. So the clinical trials and drug development method that take a long time and are tedious can be very expensive and time consuming. Additionally, this tedious method is unable to discern between relevant and irrelevant data and cannot guarantee efficient data. Okay, the data can offer useful and affordable data. In this situation, data scientists may actively manage the risk and issues during medication development. So while the medication period, the analysis by the data scientist will be helpful to take the medicines at the stages. Let us say some cancer patient, based on their level of cancers, we can do the data scientists can do the analysis on it, and the stages what need to be processed, it can be displayed out. And highlight the safety options to the corporation through the real-time monitoring of the data to identify the target audience based on many factors such as genetic structure, type of medicine required, and data scientists can also dig deep into various research data and multiple social media sources. Improved understanding of the effectiveness of sales and marketing. To do data science analytics on target clients, medical representatives have state-of-the-art equipment and knowledgeable teams. Oh, we speak about sales and marketing field. So the data science analytics on target clients, a medical representative have state-of-the-art equipments. You may simply increase your business sales and advertise them to huge crowds of people by using data analysis from social media, medical records, population records, and other trustworthy resources. Your business may stay one step ahead of its ritual, right? When you analyze the sales and marketing patterns, how to sell a drug into it. So when you analyze these kind of informations and when you've done all these things, you can come to know that this is a trustworthy sources. Your business may stay one step ahead of its ritual in the market with the use of statistical data and data sales. It may offer information about the capabilities and environment of the market. It depends. So the sales and marketing frame also requires an idea. So yeah, team, please subscribe to our 360DigiTMG channel, YouTube channel, where we are providing a lot of domains. We have covered all the algorithms there. You can get a knowledge about everything there itself. You can have an idea about it. So yeah, you have to look into it, the models. So please subscribe to our 360 digit TMG, digit TMG channel. 75 plus domains. You can choose your domain and you can establish in your life. Well, then if you want to learn Python or any other tools, I'll suggest there is a video by Barani Kumar. Barani Kumar, the Pero is the CEO of our company, organization, sufficient, like more than 17 plus years of experience, which speaks a lot, right? So you can look into the videos of him. Lot of algorithms explained by him and Python, everything given in a good understandable manner by each of the participants and each of the people around here. So I hope that he's also say to 4 different companies, uh, what we call it as chief data scientist. So you can make use of this and you can learn a lot. So please subscribe to our channel. Please subscribe to our LinkedIn team as well as 360 and Facebook as well. I hope today we are made ready. So tomorrow we will see with the things. Thank you very much for looking up the videos and appreciate that. Thank you guys.